Intro to Calc. Hope you guys are having a great day. We are moving on to Chapter 1, Section 8, Day 2. So it's about limits. It's our second day on limits. So the first video we just kind of talked about like what a limit is, the formal definition of a limit. And then today we're going to talk about more practical uses of limits. So we're going to talk about these properties, which are really nice. And help you solve limits nicely and easier. Excuse me. And then we're going to talk about different types of limits that can exist and how to deal with those. So what I have written down here, these are like in words, but then I'm also going to write down like the algebraic version or the math version of what that is. So hopefully it makes sense. I'll give you like the algebraic version and then maybe an example so that you can kind of see both situations. Okay, so the first one is you can pull out or distribute a constant. So recall that a constant is just a single number. And so if you have, say for example, the limit as x approaches 5 of 3 times x, like this, the limit is x approaches 5 of 3 times x, you can actually take the 3 out and write it as 3 times the limit as x approaches 5 of just x, okay? And so that's kind of what that would look like. So this is an example, and then I'll give you that. Okay, so the algebraic version, or the generic version, as long as a is a constant, and f of x is a function of x, then we can say that the limit as x approaches c of a times f of x is equal to a times the limit as x approaches c of f of x. So basically you could just pull out that constant, just like I did in this example. Okay, next, sum. So hopefully we remember that sum means addition. So if you add 2 limits together, then that's the same thing as taking, as long as they're the same limit, you can combine them into a single limit and vice versa. So if you have one single limit with 2 things added together, you can split that up as 2 separate limits. So as an example, to take the limit as x approaches 5 of 3x plus 2x squared, that is equal to just splitting them up and having 2 separate limits. So the limit as x approaches 5 of 3x, and then the limit as x approaches 5 of 2x squared. Okay, pretty simple. And obviously, perhaps not obviously, but you know, subtraction is just addition of a negative number. So like you could also do this with subtraction. So if this was a minus sign, then you could make this a minus sign. So then here's your generic version of that. Limit as x approaches c of f of x plus g of x is equal to the limit of f of x plus the limit of g of x. Okay, pretty simple and self-explanatory, hopefully. Let me know if you have any questions though, because you know, you never know. Okay, the next one is essentially the same thing except for multiplication. And then number 4 is the same thing except for division. And the only catch with the division one is that you can't have a denominator of 0. So I'll give you an example of 3 and 4, and then give you the generic version, algebraic version again. But it's the same thing, right? So like if I have 2 things multiplied together and I'm taking the limit of them, it's the same thing as taking the limit of one and then multiplying it by the limit of the other. Okay, so here's an example of the product of 2 limits is the limit of 2 products. This is kind of, I mean, pretty self-explanatory. This would be 3 times 5 minus 2 times 5 squared, and that's the same thing as 3 times 5 times 2 times 5 squared. Same thing. Okay, so the generic version just looks like, you know, if you have the limit as x approaches c of f times g, that's the same thing as taking the limit of f and multiplying it by the limit of g. And the only reason I'm giving these to you is because it makes, like, if you have a really complicated limit, it'll actually help you simplify it, because a lot of times it's easier to just take the limit of one thing. Hello. uh, than the other. And sometimes you might get a situation where you start with this, and this actually makes it a lot simpler. So it just kind of depends on the situation. But the idea is you always want to like try to simplify as much as you can, because that makes your life a lot easier, hence the name. All right, so here's the one for the quotient. You have a limit of 3x divided by 2x squared, and that's the same thing as the limit of 3x divided by the limit of 2x squared. And then here's your algebraic version of that. Again, one situation or one form might be easier to deal with than the other, so that's why we show you these properties of limits. This last one is pretty simple, but it actually is really helpful and allows us to essentially just plug our limits in. So for example, so what it says is that the limit as x approaches c of x is just equal to c. Okay, here's what that looks like. And basically, like, it's a very simple or more complicated way, I guess, of saying that like the limit as x approaches c of itself is the number. So like essentially I can just plug in c here to get the limit. And what's nice about that is when you get to like more complicated limits, you can start by just plugging in values of x to see what the limit is. And if you come up with something that's undefined, like for example dividing by 0, then you have to rearrange it and make it look like something else. But generally speaking, this is a good place to start. So I'll give you an example of that one real quick too. Okay, so very simply, the limit as x approaches 5 of x is 5. If you want to think of that visually, the function f of x equals x is just the line, y equals x. And so every x value is the same as the y value. So that's the 0.11, 2, 2, 3, 3, 4, 4, 5, 5. And so in this case, the limit as x approaches 5, right, my y is also approaching positive 5. So I'm kind of looking at, as I get close to x in this direction, what's happening to y? Well, it's also getting close to 5. Okay, so go ahead, try these examples. The first one's pretty simple, last one's pretty simple. They're just kind of like showing you these properties. This one is also, it's less simple because you have an extra step in there, but go ahead and try it, see if you can figure them out. So 1 and 3 are pretty simple. You should just get 2 and 5. As long as you plug in the value that you're approaching, you should get the correct y value. 2 is less so, because if you were to just plug stuff in, you'd get 2 squared minus 4, which is 4 minus 4, which is 0, divided by 2 minus 2, which is 0. And this is a problem. You cannot do 0 divided by 0. The numerator is not a problem, but the denominator is. So what you want to do is kind of like rearrange it. So I like to factor a lot and see if that helps. Factoring or foiling, just kind of rearrange stuff. So x squared minus 4 is the difference of 2 perfect squares. So that factors as x plus 2 and x minus 2. So then you have the limit. Oh, geez, I didn't even have my limit in there. That's not good. You should always like include your limit, right? That's equal to the limit as x approaches 2 of x plus 2 times x minus 2 over x minus 2. So the nice thing there is that your x minus 2's cancel, and so you just end up with the limit as x approaches 2 of x plus 2, which then you can just plug 2 in and get 4 as your final answer. Okay, so here's some more fun stuff with limits. So there's 2 different kinds of limits that you can take. There's a one-sided limit and a two-sided limit. If nothing is indicated, you're always trying to take a two-sided limit. So the two-sided limit means like you are looking from both the left side and the right side of like what is happening on the graph. So in this case, right, the limit as x approaches 1 is going to be 3, because regardless of what side I come in on, the function is still going towards 3. So that's a two-sided limit because you're like coming from both sides. And then a one-sided limit is like I'm only coming from one direction. So either from the left or from the right. And so that might be different. So for example, here, from the left direction, coming in from the right, the limit as x approaches 2 is 0. But from the left, right, as I come in from the left, the limit here is 1. So those would be two separate limits. So the way that you denote those things is you put a little plus sign on the side of the limit, kind of like I have done here in the example. So this means from the right, and then this means from the left. So a little negative sign means coming from the x's that are negative, from the negative direction, and then the little plus means from the right side. Okay, so here's kind of a general definition. So if not specified, like the limit is x equals to c of f of x, is a two-sided limit where you're looking at what f of x is getting close to as x gets close to c from both sides, from the left and the right. So you're coming in like, what's happening? Okay, so for one-sided, the limit is x approaches c with a minus as like an exponent is the limit from the left, and c plus is the limit from the right. Okay, we say that a limit exists if the limit from the left and the limit from the right are the same number, and it is actually some number. So if the limit ends up being like infinity and like blowing up and being a huge number, then you would say the limit is either, you could say that it's equal to infinity, or you could say that it does not exist. And then a limit doesn't exist if the limit from the left doesn't equal the limit from the right, or it blows up to infinity or something like that. I thought of another case where a limit doesn't exist. So it's if it's not the same from left to right, so that it wouldn't exist. If the limit blows up, then you could say that it equals infinity or it doesn't exist. And then sometimes you'll see a function that oscillates and never approaches a single number. It never kind of levels off. And that would also not have a limit. So then sometimes you want to know what happens as x gets really, 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 really big or really, 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 really negative. And those are called limits at infinity or infinite limits. And basically what you're doing is you're taking the limit as x approaches either positive infinity or negative infinity of a function. And something that will help you figure out what this looks like is you can just plug in bigger and bigger and bigger numbers of x and see what happens. Tables would help, graphs would also help, and I have an example down below that I think will make that more obvious to you as well. This plus is different than that plus. This means from the right, this means positive infinity. Okay, so here's an example, actually multiple examples. I would say pause, try them, see if you can figure them out, and then check your answers. Okay, so for this first example, 0 from the negative direction is about 2.5. 2 from the positive direction, we already talked about, is about 0. From the left is 1. And then the limit as x approaches 2 does not exist because you have two different limits that don't equal each other. And then the limit as x approaches -1, for the same reason, does not exist. And then these next couple examples are questions about the function y equals 1 over x. So it might help you to graph it or check a table for the answers. Okay, so if you graph the function, you'll see that at 0, it blows up to infinity, which makes sense because you can't divide by 0. But as x gets to infinity, like way down there, it does actually come close to 0, right? 0 is an asymptote. So the limit does exist here, and it equals 0. And that's about it. Have a good day.